to using mixed reality. Without further ado, let's welcome Frank Cunningham.
I'm Hyunsung from CMU. I'm presenting RealityReplay, detecting and replaying temporal changes in situ using mixed reality. So let me start with a quick test. I want you to observe these items closely for 5 seconds and answer my question. Does anybody remember how the scissor moved? Okay. And did anybody see me making some hand gestures here? Probably not. So as humans, we often miss important events that happen around us due to limited human capabilities. Because of our limited field of view, we cannot observe events that happen behind us or on our sides. And even if we observe them, our limited memory and selective attention hinder us from recollecting everything we saw. So RealityReplay aims to enhance users' capabilities of spatiotemporal awareness by detecting important changes in 360 surroundings and visualizing the changes in situ through a head-worn mixed reality headset. Let me walk you through how RealityReplay works with a scenario. So imagine an inventory management scenario with 2 collaborators. A collaborator arranges the inventory items on the shelf, and a user with RealityReplay keeps inventory change logs on his computer. And the collaborator keeps arranging the items while the user is typing, so the user misses all the changes by the collaborator. But the user has RealityReplay to help him play back all the changes, so the user can use the time slider to go through different time frames of the in-situ visualization changes through mixed reality. Here are some other applications. We often forget where we put our keys or glasses, so it can help us with the memory assistance to recall our unconscious actions. It can be also used for security monitoring or other applications to figure out the causality of an event. And it can also summarize events efficiently. For example, a personal trainer counting how many repetitions the trainee did while he was on the phone call. And please excuse me for the dry coughs. It's nothing contagious or COVID related. The previous works have explored extending human field of view using different camera technologies such as 360-degree vision, or having a rear camera on the back of the user's head, or having out-of-body vision using LiDAR to show live stream of extended human field of view. However, this live active monitoring of extended vision led to high cognitive load to the user. And others looked at temporal interaction of playing back events in virtual reality. However, they take an external sensing approach, which requires room instrumentation with external cameras, and their playback in virtual reality often requires virtual replica of the environment. So RealityReplay takes an egocentric approach to detect important temporal changes and generate in-situ visual summaries through mixed reality. And let's take a closer look at how it works. First, it takes input from the omnidirectional video as a rectangular frame. Then it extracts linear perspective views from the rectangular frame by computing the spherical coordinates around an anchored marker. And let's take this perspective view as an example for the following steps, and we call it primary region. Now RealityReplay detects important changes in this primary region. So it first generates candidate events through semantic segmentation using daptic object detection model. Then it uses an allow list or block list of objects to track only task-relevant events and avoid distraction. For example, the shelf is removed at this step. In parallel, it uses TasteNet to predict visual saliency of an image. So for example, the weight on the user's hand and user's head are predicted to be visually salient, which means they are likely to draw users' attention out of the whole scene. So lastly, RealityReplay combines the results of semantic segmentation and visual salience prediction to extract only the important changes happening in the scene. The tracked change is shown as a summary visualization combining motion lines for trajectory, motion history to add a temporal aspect of differentiating, and motion replay to identify which object is moving by showing the object mask. And I don't know what's happening here. Okay, since my computer crashed, I'm so sorry. Yeah, it's restarting. Yeah, I can probably go on just without the slides for now. Yeah, so after it creates all the visualizations, then it goes on to the alignment step. So if you imagine the user wearing the headset and the 360-degree camera on top of the headset, there's an angle difference between the tracking camera and the mixed reality headset. So to compensate for this angle difference, it repositions and scales the visualizations accordingly so that it matches the actual current position of the object. Yeah, then we evaluated the system using, we evaluated the system with some memory recall based tests. So basically, sorry, the computer is not working. I think I'll just have to go through our presentation.
Do we have any quick question based on the previous material?
Okay, thank you for a great talk. My question is that, okay, by your demonstration, I get that humans are not very good for replaying things. But my question is that, is there a lot of scenarios that human have to wear the big and heavy 360-degree camera on top of their head every time? Rather than that, for example, I can suggest if there's a situation that replaying some scenarios is important, why not just put a 3D or 2D static camera on the room, and if a man wants to get what the things have been done, he can just like go through the videos.
Mm-hmm.
What is the specific benefit of using a,
Yeah, that's a great question. First of all, we'd like to highlight that the current prototype we have is a study prototype to investigate the effectiveness of this approach. But in the future, we imagine the bulkiness of the headset can be mitigated by having maybe two 180-degree cameras on the side of the user glasses. And you had a good point about what's the benefit of showing these abstract visualizations versus the raw stream of the video. And we actually tested that in our evaluation as well. And yeah, so one thing is in RealityReplay, the thing we do is we extract the primary region and then compute the abstract visualizations out of the primary region. So what we did was comparing these abstract visualizations versus just showing the primary region only. And in terms of accuracy and also perceived mental load and feeling of successfulness, they showed similar performance. But the key point of showing this abstract visualization is to make it more situated in the actual reality. So instead of showing a large 2D video, it might be applicable to scenes where the user is in a solitary situation where they're just sitting in their office. But if they are in a crowded environment where there are a lot of people and maybe they don't want to occlude other parts of the reality with the large screen. So in that case, more situated and focused visualization could help.
so you mean like it benefits from the immersive experience for end user to by using the 360-degree camera. Is that right?
Right.
Thank you.
Yeah. I think it's a matter of spectrum whether we want to shoot for this more blendedness or more immersiveness of this display, or do we want to just optimize for the accuracy itself?
Or you want?
Yeah. Okay. Sorry, let me get back to this evaluation first then. Yeah, so we evaluate the performance using these two tasks. So as a primary task, the participants were asked to describe which objects moved in which direction, in which order. And as a secondary task, they responded to a target stimulus, letter K, among these white dynamically changing letters. And there were two baselines we compared to the memorized and active monitoring baseline. So for the memorized baseline, participants just memorized the initial state and then did not observe anything. And for active monitoring, they observed what is happening live. And these are the two conditions that I just explained, where we use the abstract visualization for RealityReplay versus having no abstraction and just showing the video snippet. And these were the accuracy, which shows there was an improved accuracy over the memory recall-based baselines, and lower mental load and higher feeling of successfulness. And yeah, this was also what I mentioned about the hardware design. We imagine this can be a more portable, lightweight AR glasses form factor. And it actually raises a question of privacy because continuous monitoring with an omnidirectional camera can be privacy invasive. So we believe abstract visualizations can also help with this aspect as well, compared to just showing the raw video stream of it. And also it can be further mitigated by privacy-preserving sensing approach and setting up proper protocols for who, what, when, and how to record these things. And for future works, we can explore other modalities such as auditory augmentation for a more immersive and complete representation of past events. And also supporting for various temporal dimensions. For example, do you want to replay the instant moment that you just experienced, or do you want to replay something that happened a week ago? Can be another interesting challenge for the interactions. So thank you very much. Sorry for the glitches in the technical things, but yeah, happy to take any questions, and yeah, please reach out. Thank you.
Thanks for a nice talk. Remember one more question on, okay.
Thank you for your best presentation. And I want to ask a little question about, like, at the beginning of the presentation, you mentioned the task, like, how does the scissor move? Well, actually, in reality, this kind of task is sparse around the environment. How does the reality display can distinguish which the task the user actually wants to see?
So we take two approaches. So one is what I explained in the presentation, which is more saliency driven. So the system predicts which events, which parts, or which objects in the scene are likely to grab users' attention. Another approach is more manual approach, where they can simply look at the class object classes or object labels, and then they can pinpoint exactly, I want to look at this specific event, and then they can browse through that in that situation.
Thank you.
Thank you.
Thank the speaker again. Our next speaker is Jet Tsai from